Okay, we have a 2 kilogram ball. It's going to the right at 1 meter per second. And then we have a 1 kilogram ball. It's going to the left, also at 1 meter per second. Okay, so that's before the collision. Now, after the collision, we don't know either velocity of the ball. Okay, we have to find both velocities. VA prime is a question mark, and VB prime is going to be a question mark. So we have two unknowns. That means we're going to need two equations, and the two equations are going to come from the conservation of momentum, because this is a collision that I guess we just have to assume. Yeah, the question doesn't really say, so we're going to assume the net external force is 0. Okay, that's the only way momentum is conserved. So with the conservation of momentum equation, the momentum of the blue ball before the collision would be 2. Positive, I need to choose a direction here. I'll say that the right is my positive direction. And the momentum of the red ball is -1. And then after the collision, I don't know either of the velocities. So the blue ball has a mass of 2 and a velocity that I don't know, so VA prime. And the red ball has a mass of 1 and the velocity I don't know, VB prime. I'll simplify, well, I'll leave it like that for now. I'll simplify later. I'm going to develop my second equation, which is kinetic energy. So kinetic energy I know is conserved because the question says that the collision is elastic. So before the collision, the blue ball's kinetic energy would be half. Its mass is 2. Its speed is 1. So half times 2 times 1 squared. The kinetic energy of the red ball is half times 1 times 1 squared. And then after the collision, kinetic energy of the blue ball is half times the mass of 2 times the unknown speed of ball A squared. And then the red ball, half times the mass of 1 times the unknown speed of ball B squared. Those are my two equations. There are two unknowns, VA prime and VB prime. Now, in the momentum equation, they're both vectors, and in the kinetic energy equation, they're both scalars. However, since we're in a one-dimensional situation, the magnitude of those vectors is going to equal those scalars anyway. So, yeah, we can just calculate this two equations and two unknowns. I'm going to rewrite the equations, simplified. So momentum, before the collision, 2 minus 1 is 1. And after the collision, there's nothing to simplify there. Well, I don't have to write 1.0. Yeah, I won't write 1.0. I'll just write VB prime. Kinetic energy. The left side of the equation I'll simplify. Half times 2 times 1 squared plus half times 1 squared. That, I believe, will just be 1.5. And on the right side, half times 2 times VA prime squared. Half times 2 just cancels out to make 1. And then half times 1 is going to be 0.5 VB prime squared. All right, those are my two equations and two unknowns. So I'm going to have to do some substitution. I'm going to take, I feel like I will take the equation that I'm drawing an arrow from right here. I'm going to isolate this for VB prime. Okay, so I'll subtract the 2 VA prime Okay, so I've isolated for VB prime. I'm going to take this expression, I'm going to substitute it into my second equation for VB prime. Okay, so that will generate an equation that looks like 1.5 equals VA prime squared plus half of 1 minus 2.0 VA prime squared. Okay, so that's the equation I have to solve. I wrote the squared in the wrong spot. It should be outside the brackets. That's a quadratic equation. So I'll do some simplifying. 1.5 will equal VA prime squared. And then here, got to expand all that. 0.50 minus 2.0 VA prime plus 2.0 VA prime squared. Okay, so that's squaring the 1 minus 2 VA prime and then also multiplying it by 0.5. All that put together gives me that expression. I'm going to collect everything up onto one side of the equation. This is a quadratic. I'll put it all to the right side. And I'll organize things into descending exponents. So I'll have 3 VA prime squared minus 2 VA prime. And then it'll be minus 1.0 as the constant. Okay, so that is the quadratic I need to solve, which can be done with factoring. Yeah, this is a factorable quadratic, so I believe that is the factored form there. This provides me with two answers. My first answer, VA prime, will be negative a third, or negative 0.33 meters per second to the right, because remember way back when I set my, I set my positive to the right. So this is negative to the right, which means it's to the left. And my second answer, VA prime, would be 1.0 meters per second. All right. So we get two answers here. One of them will be inadmissible if, this one will be inadmissible because, that was the original velocity of the ball anyway. It started out as 1 meter per second to the right. So it's not going to end at the same velocity. That means the balls didn't even hit each other. There was no collision. Okay, so we have our one answer there. I can rewrite it so that it's to the left. Okay, so that's the final velocity of ball A. I can back substitute it into one of my equations to get the velocity of ball B. Okay, I'm going to back substitute it into my momentum equation. So, okay, 1.0 equals 2.0 times the answer I just got, negative 0.33 plus VB prime. Okay, so then I'll just solve that for VB prime. So rearranging a bit, I think that'll be 1.67 or 1.7 if I do 2 sig figs. Okay, so that's my answer. Now I can check that by using an online simulation or an online calculator. Okay, so let me just double check here. So I'm gonna set the first ball to 2 kilograms, second ball to 1 kilogram. First ball is traveling at 1.0 meters per second, second ball at negative 1.0 meters per second. Run the simulation, and yeah, I'm getting the same answer. So this is correct.